Hey there! Today, we are going to break down a Python script that simulates the dice game craps. And along the way, we're going to see how translating some pretty simple game rules into code can actually teach us some really fundamental, powerful programming concepts. We'll learn about managing data, controlling how the program flows, and just writing cleaner code overall. So, let's dive in.
So here's our game plan. First, we have to understand the game itself, right? Then we'll look at a key Python tool for bundling our data together, something called a tuple. After that, we'll connect the dots and see how those game rules get turned into actual code. And finally, we'll wrap up with the key techniques you can start using in your own projects.
All right, first things first. One of the golden rules of programming is to really understand the problem you're trying to solve before you write a single line of code. For us, that means we need to know exactly how to play craps. So let's break down those rules.
And you know, this is really the core challenge, isn't it? How do we take these real-world rules, with all their little conditions and exceptions, and translate them into a super precise step-by-step logical flow that a computer can follow perfectly every single time?
Okay, so the whole game really hinges on that very first roll. Here's the deal. If you roll a 7 or an 11, boom, you win instantly. If you get a 2, 3, or 12, that's called craps, and you lose right away. But if you roll any other number, a 4, 5, 6, 8, 9, or 10, the game isn't over. That number now becomes your point. And your new goal is simple. You have to roll that same point number again before a 7 shows up. If you roll a 7 first, you 7 out and you lose the round. All right, now we get it. We know the rules. So let's start looking at the Python building blocks we're going to use to actually build this game. And one of the most important tools in this script is something called a tuple. So what is a tuple? Well, you can think of it as a simple container that holds a fixed sequence of items. And the key word here is immutable. It's just a fancy way of saying that once you create a tuple, you can't change what's inside it. It's locked in. This makes them absolutely perfect for storing things that shouldn't change, like, say, the result of a dice roll.
Now, check this out. This is a really clever feature in Python. A function can usually only return one single thing. But in our game, the roll dice function needs to give us back the result of 2 different dice. So how does it do that? The solution is called tuple packing. Just by writing return die1, die2, Python automatically packs those 2 values into a single tuple. It lets us pass both results back as one neat little package.
And this shows the whole process perfectly. On the one hand, inside our roll dice function, we're doing tuple packing to create that single return value. Then, on the other hand, back in the main part of our program, we do the reverse, tuple unpacking. We just give it 2 variable names, and Python automatically opens that package up, assigning the first value from the tuple to the first variable and the second to the second. It's such an elegant way to move data around.
Now, you might have noticed something a little weird here. The variables die1 and die2 are used inside the roll dice function, but they're also used inside a different function, display dice. So why doesn't that cause a problem? Why don't they get mixed up? The answer is one of the most important ideas in all of programming, scope.
And this is the key right here. The die1 and die2 inside roll dice are totally 100% separate from the die1 and die2 inside display dice. We call them local variables. Think of each function as its own separate room. The variables you create in one room stay in that room. They have no idea what's happening in the other rooms. And this is great because it prevents them from colliding and creating all sorts of confusing bugs. Okay, so we've got our rules and we've got our Python building blocks like tuples and local variables. Now it's time for the fun part, putting it all together. Let's see how those game rules we learned are translated into the actual logic of the program. Take a look at this line of code. This handles that instant win on the first roll. And I want you to focus on that tiny little word in. The in operator is just a wonderfully clean and readable way to check if a value is part of a sequence. In this case, checking if our sum is inside that little tuple containing 7 and 11. Let's just compare for a second. On the left, the code is short, sweet, and it reads almost like plain English. Is the sum of the dice in this group of numbers? On the right is how you'd have to write it without that in operator. I mean, it works, but it's longer, and imagine if you had to check for 5 or 6 different numbers. It would get really messy fast. Using in is just cleaner, better code. So what happens if that first roll isn't a 7, 11, 2, 3, or 12? Well, the script sets a variable, game status, to the word continue. You can think of this variable like a light switch. It tells our program, hey, the game isn't over yet. We need to keep going. It's the trigger to enter a loop for all the next rolls.
Let's just walk through a quick example game. So on the first roll, let's say the player gets a 1 and a 5. That's a total of 6. Since that's not an instant win or loss, the game has to continue. So now the code sets the point to 6, and it flips that game status switch to continue. This kicks off a while loop, and the whole objective of the game changes. Now the player has to roll a 6 again before they roll a 7.
Okay, so on their very next roll, what happens? They get a 1 and a 6 for a total of 7.
And that's the game. Because the player rolled a 7 before they could roll their point of 6 again, they lose. The code sets the game status to lost, that while loop stops running, and the game is over.
So, just by building a simulation of this simple dice game, we've actually uncovered some really practical and powerful programming ideas. Let's do a quick recap of what we've learned.
First, we saw how tuple packing and unpacking is an awesome trick for returning multiple values from a single function. Second, we really dug into the crucial idea of local variable scope and how it keeps our functions from interfering with each other. And third, we saw how using the in operator can make our code so much cleaner and easier to read.
You know, the skills we just used, translating rules into logic, managing data, controlling the flow of the program, they aren't just for games, they're universal. You can use these exact same ideas to model a financial process, a scientific experiment, anything. The core logic is exactly the same. So the real question to ask yourself is, what problem are you going to model next?